Hi everyone, let's solve this problem. Jump game 2. You are given 0 indexed array of integers nums of length n. You are initially positioned at index 0. So you are basically at the 0th index initially. Each element represents the maximum length of forward jumps from index I. So basically, if you are at this particular position and the max jumps is 2, that means you can either take one jump or you can take two jumps and you can reach the index 2. That's what they are saying. Return the minimum number of jumps to reach index n minus 1, nothing but the last index. The test cases are generated such that you can reach index n minus 1. So all the test cases are such that if you start from the 0th index, you will always reach the last index. That's how the test cases are. Now we have to find the minimum number of jumps. So for this, we are going to use greedy approach, and let's understand how we can solve this problem. So basically, instead of considering individual element, we are going to consider ranges. So every range determines number of steps. If there are 3 ranges which we could take, that means there are 3 steps to reach the end. That's how we are going to determine. So range will have a left pointer and also a right pointer. Let's say for example this is the range, that means left will be 1, right will be 2. So initially, since I am starting at 0, my left and right range would be 0, 0 and 0. So now in this case, if I can move 2 steps, that means 1 and 2. Either I can take 1 step or 2 steps. So if I have to update this, left will always be updated with r plus 1, because once I finish this range, I have to start from the next element itself. So r plus 1 would be 1 here, and r would be the maximum in this particular range. I plus nums of I is 2. So this will be the range. So in case of step 0, my range was just 2. In case of step 1 now, my range is 1, 2, that means 3, 1. This is my range. Now again I'll find the maximum. 1 plus nums of I is 3, 4, max is 4, or 2 plus the value at that particular index is 1, 3. So max of 4, 3 is 4. So right will, so before I update right, I will be updating left. It will be r plus 1, r is 2, so r plus 1 will be 3. So maximum of this will be the right, which is nothing but 4. So now at my step 2, the range would be 3, 4, because L and R, and this is it. And if you see, R has already reached the end of the index. That means we kind of reached the last index. Now we have to calculate the number of steps. If you see, I was at this particular position, which means 0 steps. I haven't taken any steps. It was initially there, and I have taken 1 step, and I got the range of 1, 2, which has elements 3, 1. And then from this range, I took one more step where I could jump to the indexes 3, 4, and the values are 1, 4. So this should be 1, 4. Yeah, and R reached the end. So that means we were able to get the number of steps as 2. So let's try to write the code for this. Initially, R will also be 0 and steps will be 0, while R is less than nums dot length minus 1. What we have to do is we have to get max value. Max value is initially 0. I will be iterating now between the range I, L and R, I plus plus. So max value would be math.max of the current value which I have, or I plus nums of I from a particular step, number of jumps. So that will be the maximum value. Once I get this, L will be r plus 1 as we discussed, R will be the max value, and number of steps will be increasing, and then we will be returning the number of steps from our answer. So this will be the minimum number of steps, because we are kind of taking in ranges. So if you see here, if it was 2 jumps, this was the range, and maximum jump from here was 3, so this is the range. So that's the reason we got steps as 2. Now let's run it. Okay, it's steps. Let's submit it. And then the time complexity of this solution is big O of n, because we are just iterating over every element at max once, and the space complexity of this solution is big O of 1, because we are not using any extra space apart from couple of variables that wouldn't count as like that would be counted as constants. So I hope the solution is clear. Thank you.